So, even though I will be specifically talking about lithium ion battery charger, but the concept is applicable to any other battery. So, but since most of our handheld devices or portable devices use lithium ion batteries, even the electric vehicles these days are using lithium ion battery. So, this is more popular. So, lithium is the lightest metal, that is one of the main reasons it is used in a battery, and lithium can release as well as accept electrons, and that is why it can be charged and discharged actually. So, it has quite high density, almost 2x of your standard nickel cadmium battery. You would have seen those cylindrical batteries, 1.5 volt battery, which is we used in remote controlled and toys and everywhere. So, and the voltage here is typical 3.6 volt, which is almost 3x as I so your nickel based cells are 1.2 volt, some cells are 1.5 volt also. So, almost 3x. So, that is another advantage, you get a higher voltage, higher power density, and then it is a very light. So, even if you can take those cylindrical 1.2, 1.5 volt batteries and look at the battery which is used in a cell phone, you can compare the weight. So, it is very light actually, lithium ion. So, how it works during charge phase, your lithium ion migrates towards negative electrode and they store electrons from external energy source. So, you have plugged in your charger. So, these lithium ions will move on this side, and so what will happen during the charge discharge phase, when you connect your load, basically they will move back to other side, or from cathodes, from anode to cathode side. Okay. So, and they will release the electron. So, and basically that is how the current flows actually from your battery to load. So, and when the battery is fully discharged, again you will find in this state, left hand side, okay, and then again you have to charge back in order to use the battery again. So, during this charge discharge phases, some of the ions are trapped. So, and based on that, they have a limited charge discharge cycle, maybe 1000 cycles also. After that, your battery will be dead. So, that is why you cannot have an unlimited number of charge discharge. There are other factors also, reliability factors, like if battery is heated too much and all those. That will reduce the life of your battery as well. So, a lot of protections is involved there in the battery in order to make sure that battery life is extended. So, if you look at a lithium ion battery pack, so even though from outside it looks like just a battery, there is inside very little small PCB which contains some circuitry there, and I will mention about that what exactly those are. But if you look at a battery, old days we used to have only 2 terminal batteries. One will be your VDD, like V supply, and ground, which we call VBAT. VBAT is nothing but battery voltage, and then ground. Then nowadays you will find either 3 terminal or 4 terminals batteries. Okay. So, what is the third terminal here? So, third terminal may be your BTH or BAT-ID. BTH is your battery thermistor. So, as I mentioned, when the battery is heated up, it cannot sustain very high temperature. So, there are some reliability reasons and safety reasons also. There is a risk of explosion as well at high temperature. So, you have to limit when you are charged, and most of the time battery will get heated up when you are charging. You would have seen when you plug in your charger, your phone will be heated actually. The temperature of phone will be much higher compared to the room temperature. So, so there is this thermistor is connected between this terminal to ground, let us say, and you can monitor that temperature, and that temperature will be mostly inversely proportional to temperature. So, when temperature increases, that voltage will go down. You will compare with the reference, and you can basically either stop charging or reduce the charging current based on your temperature limit actually. So, let us say the maximum temperature you want to stop charging is 150 degree also. So, at beyond 150 degree you do not want to even charge at all. So, you can completely stop the charging, but let us say when you exceed 100 degrees Celsius or so, you can start reducing the current, so that temperature will not rise that much. So, you can maintain a temperature below whatever maximum limit is by simply reducing the charging current. So, that is why this thermistor is used, which is connected at BTH, and that is what the third terminal does. In some cases, instead of thermistor, this third terminal can be used as BAT ID, which is battery ID. So, and this is again used to connect ID register. So, and which contains the battery information such as battery type, capacity, etc., used as a serial, and it can also be used as serial communication port. So, when battery is plugged in, if this is being used as BAT ID, so your phone or any device can read the voltage across the battery. So, let us say a constant current is being sourced in that resistor, and the IR voltage across that will, you can determine the value of the resistor from there, and based on that value of the resistor, you can find what is the what type of battery it is, what voltage it is. So, all the chemistry and what capacity it has, all those information can be found from that resistor value. So, there will be a, I mean, it basically comes from the standard battery standard, that there will be a table of your RID, and if your RID lies between in this range, so this will be the all details of the battery, what is the capacity and all those. So, let us say if it is a 1000 milliampere hour battery, the RID may be, let us say 1 kilo ohm roughly, I am hypothetically saying. If it is a 2000 milliampere hour, then RID could be 2 kilo ohm, so, or 2 to 3 kilo ohm, something like a range will be given. So, if it lies in between that. If it is being used as serial communication port, then it is a single communication, there is no clock. So, it is a non-synchronous protocol, it's used. So, so in that case, your battery can communicate with the host or your device, your cell phone. So, from that it can provide all the information. So, whatever information you are getting from RID, you can get that same information digitally. This battery will have the its own controller, and it can communicate with the phone or your laptop, whatever. So, and there is something standard called like MIPI-BIF, which is a MIPI standard battery interface, and this is mainly used for that. So, that single terminal can provide all the information, and there is a complete MIPI-BIF controller on this inside the battery actually, and that is called a smart battery. So, because it can tell all the, it can in fact tell you when you are charging the battery, it can tell you what current it is being charged at, it can even tell you what voltage it has charged to. So, a lot of things I mean can be done within the battery itself, what is currently being done on the phone side. So, for example, your cell phone need to measure all the current, all the voltages when it's charging or your battery is discharging for battery management applications. So, all those information can be provided by the battery itself. So, a lot of things which is currently being done by the cell phone, the battery will be doing everything. So, another purpose of that would be like it can identify itself through that digital communication port. So, each battery will have its own unique ID. So, it can be used for authentication purpose. So, when that unique ID can be verified by the phone, and phone will know whether it's a battery you have plugged in, it's a real genuine battery or it's a duplicate battery actually. So, a lot of duplicate batteries are there in the market. So, and those batteries are not reliable. I mean, most of the time the risk of explosion and all those is with those batteries. So, to avoid that, in order to check whether the battery is genuine or not. So, let us say the real battery is capable of basically capable of charging at some 4 amp or so. I mean, I am saying because these days you have fast chargers. So, those fast chargers I mean they can charge the battery at very high current. So, but you need a actual real battery in order to charge 4 amp, the battery which can accept 4 amp current. But let us say you have a duplicate battery which cannot accept 4 amp. I mean, from outside it may look same, but inside the chemistry is completely different. So, if you charge the same battery with 4 amp, it may explode. Okay. So, in order to avoid those kind of situation, what would happen if cell phone detects that it is a fake battery or it is a duplicate battery, not real battery through this digital communication port. So, when the cell phone, what cell phone will do, it will ping this battery over this phone and ask, okay, can you send me your UID, unique ID. The battery will send the unique ID, and if it will basically see whether that unique ID is real or not, or whether the battery can communicate or not. It is quite possible that battery may not be able to communicate, because those are cheaper batteries and they will not put the whole controller here, MPP obviously. So, when the cell phone does not get any answer from the battery, it will imagine that okay, this battery is not real. So, it may either will not charge the battery at all, or it will charge with a very low current actually. So, just to make sure that there is no risk of explosion or damaging your cell phone. So, this is very important port, this BAT ID for I mean temperature monitoring as well as communication purpose. In some cases you may have a separate BAT ID, and so this is a 4 terminal battery. So, that is also quite possible. You may have a one BAT ID port and one BTH which is connects the thermistor. Okay. So, let us see what is inside this lithium ion battery pack. You have a protection circuit to prevent the battery from over voltage during charge. So, when you are charging your battery, so this battery have a specified maximum voltage. If you charge beyond that, again I mean there is a risk of explosion, battery explosion or damaging the battery itself. So, we cannot charge beyond certain limit. So, let us say the battery maximum voltage is 4.6 volt when fully charged. If you charge it even few tens of millivolt higher, it will be at risk actually. So, that is very important, we cannot overcharge the battery. So, there is a circuit which will detect the voltage. If it is overcharged, then it will completely cut off, or if it is again the same problem may happen, you cannot over discharge also. So, there is a minimum specified voltage below which you will not allow your battery to discharge. Okay. The problem is if it goes below that voltage, then in order to bring back to that voltage, it may take forever to charge that battery actually. So, very long time, because when battery is fully discharged, you cannot charge that battery with high current, because if you charge with the high current, then again there is a risk of damaging that battery. So, so that is why this protection IC will not allow to charge or discharge a battery beyond certain limit, and that is why we use it. And it can have a overcurrent protection also. So, if you are charging more than the specified current, then that can also be detected and it will cut off the charger. So, and then you have a thermistor, just like I said, you have a BTH terminal which connects this thermistor with the ground. So, which monitors the temperature, battery temperature, and then ID resistor is connected between BAT ID and this ground. And if you have this as I mentioned, if this is being used for serial communication, then you will have you may have another IC, or that IC may integrate both the controller as well as protection, everything. So, there will be a complete transmitter receiver actually for that serial communication. So, if you look at a lithium ion battery discharge profile, this is how it looks like. So, typically your voltage will fall in range of 3.3 to 3.6 volt, and when it is fully charged, it may be 4.5 to 4.6 volt, and this is your charge cutoff voltage which I was mentioning. And then when you are fully battery is fully discharged, then it can be somewhere between 2.7 to 3 volt. Okay, below which its unused capacity. The reason unused is because you can see the voltage drop is very quickly here. okay, and this region is mostly flat region. So, this your working voltage span is mostly this, because here also you can see the voltage is discharging very fast. So, maybe within few minutes if you connect the battery, it will fall to this voltage, but most of the time it will remain within this range, which is mostly this flat curve remains 3.3 to 3.6 volt. Okay. When it goes below 3 volt, you mostly cut off, and this is the point where you say your battery has charge has gone to 0% actually capacity. It is not a 2 volt, but if it goes below 2 volt, then you completely discharge the cutoff, then your protection IC will kick in, but this portion is taken care inside the phone charger itself. The phone will not allow the battery to discharge below this, but let us say due to leakage or any other reason, if battery is, so let us say you keep your cell phone for a month or so, and due to some reason your battery is being discharged and goes below this level, then that protection IC will cut off that battery completely from the, so it will be a completely open circuit by opening this FET. So, then your charge will remain, the voltage will remain at 2 volt, that is it. So, there are some useful definitions which you need to remember when you work on these charging circuits. So, capacity is one thing, battery capacity always measured in milliampere hour. Okay. The reason is basically if, so 1 milliampere hour when I say, or 1000 milliampere hour, sorry 1 ampere hour or 1000 milliampere hour, which means if you draw from that battery constantly 1 amp current, then it will last for 1 hour, that is what it means. 1 amp, 1000 milliampere hour, 1000 milliampere hour is nothing but 1 amp. So, if it is a 1 amp power battery, which that means if you draw 1 amp constant current from that battery, then that battery will last for 1 hour, that is it. If it is a 3000 milliampere hour, then you can draw constantly 3 amp for 1 hour or 1 amp for 3 hours. Okay. So, that is why capacity is always measured in milliampere hour, not in watt actually. Watt is different. Watt is, then you have to multiply with the voltage, and that voltage is not constant here. So, that is why it is always given in milliampere hour, and it varies depending upon size. So, it could be as low as 100 milliampere hour. If you see your old style phones which had like a black and white screens and all those, they will have a very small battery. So, capacity is only 100 milliampere hour, and the power consumption of those phones is not so huge. Even 100 milliampere hour battery will last for 2 to 3 days. Okay. So, or if you look at your Bluetooth headset, okay, or your smartwatch, the battery, I mean you cannot put a bigger battery there. So, as you increase the milliampere hour, then your battery size also increases. So, that is proportional to your battery size. So, and when you go like 3000 or 4000 milliampere hour, you will see a very big battery used in the phone. So, if you open your phone, most likely it will be like 3000 to 4000 milliampere hour battery, if you have a smartphone which is 5.5 or 6 inch kind of a screen. And now you can imagine the power consumption of the phone, that even 4000 milliampere hour battery, if you charge in the morning, then by the evening it will be fully discharged, if depending upon usage. And most of the average use we have, it lasts only for a day or so. If you measure with the voltage level, then you are not actually measuring the capacity. The capacity is always milliampere hour. So, how much current you are drawing from for how much time, that will tell you. It is like a Coulomb count. Current into time is what? Charge. So, it is always, it is storing the charge. So, you have to measure the capacity in the charge. Voltage level will not give you a real number. It may give you maybe some number, but that will not be accurate. If you want to accurately measure the capacity, then milliampere hour is the only way to measure is. Another reason is so with the time actually what happens, your let us say you have a new cell phone, the battery may be lasting for a day or so. and when you are charging, the charging time will also be high when a new battery. After a year you will see your battery will be charged quickly and it will discharge quickly also. So, what happens due to aging, when the battery gets older, the capacity of the battery itself starts reducing. So, if you have a, let us say 1000 milliampere hour capacity battery, after a year only 500 milliampere would be left capacity. So, in reality the 100% battery for older battery is only 500 milliampere, and for a new battery is 1000 milliampere hour, even though they might be same battery, but it is only because one is old, one is new, and this mainly because of aging factor, and that is why we say it has 1000 cycles of charge discharge, because what happens after 1000 cycles of charge discharge, the capacity is almost 0 actually. Your battery will not last even for few minutes. So, if there is no capacity, then you cannot use that battery at all. So, that is why in the reality, if you want to measure the capacity, it has to be measured. So, since it shows a percentage, so it will only show when it is fully charged or fully discharged. Okay. But if you want to tell real capacity, then 100%, like I said, the older battery has a capacity of only 500 milliamp, and when you started a new phone, the 100% capacity was 1000 milliampere hour. So, in reality the old phone should show only 50% capacity when it is fully charged, not 100%. Okay. So, this is the one thing we basically not very accurately done in most of the cell phones, which may needs to be done especially in case of electric vehicles. In the electric vehicles, if you are, let us say after a few years, 2 or 3 years, your battery is capacity is reduced, okay. And initially when you started with a new car and new battery, you are in one charge, let us say it was going let us say 100 kilometers. After a year, it is able to go only 50 kilometers. So, in the capacity, it should only show 50%, so that you know that it will only go 50 kilometers, not 100 kilometers, just like your petrol tank. If you fill it is a full tank is full, then I mean when it is a full tank, you know that if you, depending upon what mileage you are getting, you can say that okay, it will go maybe 500 kilometer or so. Okay. But if your tank is half only, then you know, I mean you can guess how far it will go. But in case of electric vehicle, if in both the cases it is showing 100%, then it is very difficult. So, in reality the measurement should be just like you measure the fuel actually, the petrol tank. Even though your petrol tank measurement which is shown, that is not very accurate, but still it will tell you whether it is half full or full, 100% full. But in case of when they show the battery level, they will just look when it is fully charged or fully discharged or mid charge, that is it. They will not show what the real capacity is. So, but this is really important actually, and eventually in it will come up, and it will start measuring the real capacity which is left in the battery. Based on that, it will show the level. Okay, charging rate. So, it is defined as C, where 1 C means whatever the capacity of battery is. So, let us say it is a 3000 milliampere battery. So, when I say 1 C, that means 3 ampere. Okay. And so, you can charge that battery when you are charging at a full rate, you will say you will charge at 3 amp, 3000 milliampere hour battery. If it is a 5000 milliampere battery, then 1 C is 5 ampere. When I say 0.1 C charging rate, that means 1/10 of that. So, 1000 milliampere hour battery, if you are charging at 0.1 C, then you say you are charging at 100 milliampere. Open circuit voltage. So, open circuit voltage is nothing but when nothing is connected to the battery. So, your battery is completely disconnected from the load, you measure the voltage. End of the charge threshold. So, this is a minimum charging current below which battery is supposed to be fully charged. Okay. So, when you are charging your battery, what will happen when it is fully charged, then you have to cut off the charge. So, what you do, you start reducing the current, and then there is some minimum current below which you can say that okay, now battery is fully charged. So, that is called end of charge. So, there are different charging phases in the battery, and this is really important actually in order to, if you are designing a battery charger, then you need to know these things, otherwise your charger will not work at all, or if even if it is able to charge the battery, it will damage the battery completely. So, these phases are really important. Trickle charge. Trickle charge is a battery charge with the lowest current, the minimum current actually, which is 0.01 C, and 0.01 C is 1%, 1 to 3% of your full capacity. So, if it is a 1000 milliampere hour, then you can say 10 milliamp to 30 milliamp only. Okay. If it was discharged to very low, 2 volt or below, that is what I mentioned, if that is the level 2 volt, below which you do not allow, but if it is allowed, then you cannot charge with the high current, then it may take forever to charge. I mean, you may be sitting half a day to get your battery to even come to the level 3 volt, where you can start charging with the full current. Okay. So, this charging state remains until cell voltage reaches to 2.6 to 2.7 volts. So, this is the minimum voltage where now you can start charging with higher current. Okay. When say higher means higher than this 10%. So, sorry, this is 1 to 3%, the next level is 5 to 10%. So, now from here you can move to the next level, which we call it pre-charge. Okay. So, most of the time your battery or your cell phone does not allow your battery to discharge below this volt. So, this will be your 0% actually. So, from 0% when you charge, you will be starting from pre-charge, you will not be starting from trickle charge. But due to some reason, as I mentioned, if you keep your phone for a month or so unused, then due to leakages it may go down, and then when you connect the charger, then you have to wait for very long time in order to get to pre-charge phase, and then after that your battery will start charging quickly. Okay. So, 0.1 C between 2.6 to 3 volt. Then constant current charge, this is the full current charge which happens here. So, battery is charged with full current, which is usually 1 C, and 1 C I already mentioned, it is nothing but your battery capacity, and above 3 volt until voltage reaches to 95% of the full voltage. Okay. So, then we enter the constant voltage charge. The reason is I cannot charge battery to 100% with the full current. Otherwise, you cannot accurately stop the charging at the maximum allowed voltage. So, you have to basically start reducing the current before you little before that. So, let us say 95%. So, after 95%, now you know what is the maximum allowed voltage, you enter a constant voltage, so that your battery voltage will be regulated. So, this constant voltage mode will automatically start reducing the current when battery is charging up. When it is fully charged, the current will be almost 0 automatically, it will be taken care of. So, then you can cut off the charge. But if you keep in a constant current mode for 100% time, then you can, it is quite possible you can overcharge the battery, and there is a risk of damaging. Think about a regulator. So, your regulator is now starting. So, when the regulator will stop charging the capacitor, output capacitor, when it reaches to the full voltage. So, now it is a 95%, correct. So, after 95%, now you enter the constant voltage mode. So, what would happen? Your feedback will be coming from your battery, and you have a reference voltage, and reference is, let us say, telling that your feedback voltage will be same as Vref when battery is 4.6 volt. Okay. But the when you entered, the battery was, let us say, how much? Let us say 4.5 volt, 100 millivolt below that you entered into constant charge. So, 100 millivolt now more you have to charge, correct. So, your constant voltage regulator will automatically make sure that your it will keep supplying the current until it goes to 4.6 volt, okay, and then it will stop charging automatically, because your feedback will not allow to charge the output further. So, your current will gradually start dropping, and you can look at when you start your regulator, let us say you build an LDO, when you start it, even if there is no load, the there will be some current drawn from your power FET in order to charge that capacitor to the final voltage. But when it charges to the final voltage, current will stop. That is how capacitor is charged. So, the same thing happens here also. So, you can imagine your battery is nothing but a very huge capacitor. Okay. So, these are different phases you can see here. This is your trickle charge, which is like 1 to 3% I mentioned. Then when your voltage level reaches here, this point, okay, then you enter the trickle charge, which is 2.6 to sorry pre-charge 2.6 to 3 volt. So, then you when your battery voltage so and this level is actually programmable. Some batteries may have a 2.7 volt, some may have a 3 volt. So, it is not really fixed, but most of the time the minimum could be 2.6 and maximum could be 3 points. So, but it could be anywhere in between this. So, this is your so it will remain in pre-charge phase until this voltage, okay, and then from here it will take off and you enter into full charge, which is a constant current phase you call, and you can see here you are charging with 1 C. Okay. So, but one thing you need to remember, I mean in the old days these batteries used to be charged with 1 C only, but nowadays you have fast chargers, they can charge the battery with 2 C or 3 C actually, a much higher current. That is how you get a fast charging, like in 20-30 minutes you get like 50%, 60% battery is fully charged, charged. This is battery voltage and this is your current. Look at the profile, charge discharge profile. Most of the capacity is here. So, voltage will be changing slower because I mean think about, you have a big capacitor. In this range your capacitor value is small, but in the middle range your capacitor value is 10 times more. So, even if you charge with the higher current, your charging rate will not be that fast. So, basically the capacity is different in these cases. You can see here it is falling quickly, here falling quickly, but here it remains much flatter. So, that is why your this is different. It does not mean that it is not a constant like a constant capacitor, that if you charge with the higher current then your charging rate will be higher. Okay. So, then you can see here when you are near charge, then you enter here in the constant voltage, and this curve is shown for lower voltage battery, which is 4.2 volt. So, you can imagine that this battery has a maximum voltage of 4.2 volt. So, it is not necessary that all the batteries will have 4.6 maximum voltage. There could be some batteries which may have 4.2 volt max, but over the time like batteries have improved, and nowadays you can see 4.5 or 4.6 volt when they are fully charged. But I mean few years back those batteries were only having maximum voltage of 4.2. So, those are the improvements which are basically being done in the batteries to increase the voltage level, so that you can get more capacity and battery will last longer. As I mentioned, you never know whether battery is genuine or not. Okay. So, if it is a genuine battery, you are using genuine charger, everything, then all the protection circuitries are there. Okay. I mean there are a lot of low end phones which, even though you call them let us say smartphone, they will give you all the features, but they do not have a genuine part inside. So, you do not know what chargers are being used there, where all the protection is there or not. So, it depends on that as well. Let us say the battery is does not have a thermistor at all, what will you do? It gets overheated and it may explode. So, the cheaper batteries, they will try to reduce the number of parts as much as possible, because they are much cheaper compared to the original batteries. So, most of the time I mean there are very rare cases where you will find genuine battery would have exploded actually, and you do not know under what conditions, why, but most of the time risk risk is there when your battery is getting charged, okay, or if battery is getting discharged with a high current, then again the same thing actually. So, it may get overheated and explode.